Okay, so let's go over question 5.3. Okay, so this question essentially asks of you to determine of a very nasty molecule, where will it be protonated? And we have two options. So if you put the molecule that is just the normal unprotonated version, if you place it in the region of some sort of acid like HCl, where will it protonate? Will it protonate on this nitrogen or on that nitrogen? And you can go about this using different ideas. So for example, you can use your normal hybridization theories. In other words, p orbitals, sp2 orbitals, sp3 orbitals, which ones are more likely to be protonated, which ones have an energetic favored protonation, and also the molecular orbitals of this molecule. What type of molecular orbitals, where do the molecular orbitals lie? Do the molecular orbitals, where does the HOMO and the LUMO orbitals lie? So in other words, think about, is the electron donation, is this a Lewis acid or base? Is it going to accept electron density or donate electron density? In other words, on which atom does the HOMO or LUMO lie, and how does that influence the bonding that is going to occur once that protonation occurs? You can also think in terms of the stability of the orbitals. So draw the product and look at the orbitals and see how the orbitals change from the starting reagent to the product. Okay, so that's the orbital argument. And I started to alluding to stability, and we can get into stability is the second argument that you can also use. So continuing on with the stability argument, for example, which one of these products will be more stable? And how do we answer questions about stability? Well, we usually look at thermodynamics. In other words, Gibbs free energy is usually our go-to to look at for product formations. In other words, whether or not something is going to be spontaneous. Remember, in your second year, you consider whether or not reactions are spontaneous based on their Gibbs free energy. In other words, spontaneity is connected to the concept of whether or not something is possible. So if it has negative Gibbs free energy, then it means the reaction will occur spontaneously. Positive Gibbs free energy means it won't occur spontaneously. You can consider that. So in other words, a reaction pathway, compare the product and the product and the reactants, see which one has what tendencies. Okay, I think this is more than enough help. I hope you will be able to construct your arguments using these ideas.